So at JPL, we're just starting a project where we're going to try to improve the use of GNSS data in these combined reference frames. So for JTRF 2014, we use GNSS data in the standard way, where we don't allow it to contribute to the scalar, the geocenter. And we only use data from ground GPS receivers, GNSS receivers. We're going to do a set of solutions where we're going to relax that constraint and allow GNSS to contribute to the scale in the geocenter, again using just data from ground receivers. And then we're going to use, do some solutions where we use both ground and space-based receiver data from ground and space receivers. And this is the solution that Bruce Haynes did last year. But to start, I wanted to do a solution where we don't use any GNSS data at all, just as a baseline solution for this project. And the way we've done this is to take JTRF 2014 and simply delete all GNSS data. And this solution was done by Claudio, and he provided these slides, which I'll be showing. So the input data is the same data we use for JTRF 2014, which is the data that the services provided for ITRF 2014. And our solution setup is exactly the same as we did for JTRF 2014. And after we edit that data for JTRF 2014, this was our network, 972 stations. And if we remove the GNSS data, we're left with 301 stations. So there's 671 GNSS stations in JTRF 2014, which are not included in this no GNSS version of our frame. We still have a pretty good distribution globally, thanks to the strong DORIS network. Okay, so so after we remove those GNSS stations, we're left with 71 VLBI, 71 SLR, and 159 DORIS stations. Now, when we remove GNSS, we also remove all the site ties. So the site ties are reduced by about half. So instead of having 220 or 30, we're left with 116. In that reduced network, if we look at the fit to the data, the reduced chi-square, the station positions and the tie vectors are still reasonable, right? They're still close to 1. But the reduced chi-square for the EOP observations is 0.75. So again, in this solution, we are not trying to determine an optimal frame based only on VLBI, SLR, and DORIS. Instead, we're determining, we're looking at the impact that GNSS had on JTRF 2014, and the weighting, even without GNSS data, is still reasonable for station positions and tie vectors, but not for EOP, and that gives you a hint that the GNSS data is important for the EOP in this solution. Okay, so this is where we compare the Helmholtz transformation parameters between the no GNSS version of JTRF 2014 and JTRF 2014 itself. And what we see is that, let's see, where is this thing? Oh, there it is. Yes, okay, thank you. So what we see is that the transformation parameters are really less than the error in their determination, except for, particularly except for RY, the Y component of the rotation. So the two frames, the no GNSS and with GNSS, are not statistically different from 0, at least at the 2 sigma level. But let's compare the frames to ITRF 2014. So here we are comparing the translation parameters, all right, TX, TY, and TZ, along with the scale on the left-hand side, we have the no GNSS version, and on the right-hand side, we have JTRF 2014. And what you see is they're both pretty similar, right? The translations and the scale are, compared to ITRF 2014, are pretty similar. Doesn't really matter whether you include GNSS data or not. And this is what we expect, right? We don't allow GNSS to contribute to the geocenter and scale, to the translation and the scale, and so we don't expect it to have much of an impact on those parameters when we remove that data. But now let's look at the rotations. And so here we're seeing a bigger impact when we remove the GNSS data. So there's, so in particular, where was this thing? So in particular, we're seeing larger rates in the rotation parameters that are not appearing when we include GNSS. And so since it is affecting the rotations, we expect it to affect the EOPs as well. So this is the comparison of the EOPs with the GNSS-free version of JTRF 2014 to ITRF 2014 and JTRF itself. And you see that there's much greater scatter when you're in the combined EOPs when you remove the GNSS data, particularly for the polar motion. And then this is the rates. So this is polar motion rate and length of day on the bottom. Again, much greater scatter. We have statistics on this. So the RMS differences without GNSS data is really, it increases a lot on the EOPs. Okay, what about the effect on the station positions? And these are the station velocities, and we're plotting on these scatter plots on the y-axis is the no GNSS, the station positions in the no GNSS version on the frame, and on the x-axis it's with GNSS, right, JTRF 2014, and separated out by technique, and we're seeing that for the horizontal components, there's a nice spread in amplitude, in value of the station velocities, and it's quite linear, so that, and there's a high correlation, so that the station motions are pretty much the same in the two frames. For the vertical, which is the last column there, the height, there is a bit more scatter in there, but the range and the motion is also much smaller. Effect on geocenter motion. Here is the station distribution that we used for the no GNSS version of determining geocenter. We had to include 10 Doris and 4 VLBI stations in this to get a reasonable global network to do this. And of course, this is different than the network that we used to determine the JTRF 2014 geocenter. And when we do that, well, this is first JTRF 2014. This is the geocenter we got in our solution we submitted to the IRS. And when we remove the GNSS data, we get this solution. And they're similar. I'll flip back and forth between them. There is some long period differences, but overall quite similar. And we have statistics on this. And so the annual amplitudes and phases are quite similar to each other between the no GNSS solution and the solution with GNSS, as is the semi-annual, although there's bigger discrepancy in the semi-annual case because it's a smaller signal. So in conclusion then, what we have done here is a first attempt at determining a solution based only on VLBI, SLR, and Doris data. The goal of this solution was to study the impact of GNSS data on JTRF 2014. So the only change we made was to remove the GNSS data from JTRF 2014. We made no attempt to reweight the VLBI, SLR, or Doris data in this solution. If we did that, we would most likely get a more optimal, no GNSS frame, and we will be doing that soon. What we found is, not surprisingly, there's very little impact on the geocenter and scale because we're not allowing GNSS data to contribute to those frame parameters. But there is a big impact on the rotation parameters and the EOPs. So in particular, the GNSS data provides an important rotational constraint to these combined frames, and of course it's important for the combined EOPs, which would allow better agreement with the celestial frame, which is what you need those EOPs for. And the horizontal components of the velocity fields are very similar, between the two solutions. So the GNSS data doesn't really affect the velocities of the remaining VLBI, SLR, and Doris station, which wasn't clear because there are co-motion constraints involved in this. And so I think that's all I have.